The first thing here is we're going to look at masks. What's a mask? It's a NerveCenter tool for listening for a trap, right? A standard SNMP V1 trap has this format. There is an enterprise ID, there is an agent address, there is a generic trap type, there is a specific trap code, there is a timestamp, and then there are variable bindings. And you'd notice I didn't say a variable binding, but there are variable bindings. They number from 0 to 255 possible variable bindings. That is up to the vendor as to how many he attaches or they attach to their specific trap. But there can be up to 256 of them. Any packet that comes in this format if it's a trap. IF entry .if type 1 equals 6. What does all of this mean? It means that in an incoming trap, I can usually extract, and I can probably say pretty reliably extract, any of those three statements. That the base object, the attribute, the instance, and the value are there. They're probably in the variable bindings, but it's there. From IF entry, IF type, to IF entry description, to system, sysdesker. They're always in the variable bindings. Which one? That becomes the difference between the vendors. There's no standard as to how it is sent. You may have to sit there and actually read the incoming trap into a log file and sit there and count the var binds to figure out which var bind it is. An alarm state diagram. Well, we've created a trigger. We need to take the name of that trigger and use it someplace to create an alarm diagram that moves from a state to another state, possibly to a third state. In the case of this example, from ground to busy to too busy. If I were in the ground state, would I see this in the alarm summary? No. It hasn't fired a trigger. It's in ground. It's not tracked in memory. It's not instantiated. However, if I receive a port traffic trigger and this alarm is turned on and the mechanism that defines the port traffic trigger is turned on, this is a pending transition. Port traffic is the transition that comes out of ground, and when it's turned on, it becomes the pending transition, and NerveCenter keeps a list of pending transitions in memory so that if something happens out there and one of these things becomes evaluated to true, it knows where that pending transition is and can fire it for us and start to move that alarm along. It's tracking the transitions, and once it tracks the first one off of ground, it tracks that in a specific list called the alarm summary. We go here to create an alarm state diagram by going to the alarm definition list, clicking on new. It opens one of these windows for us that is blank. The only thing you will see when you open a new alarm definition window is the ground state. Nothing else is there. You get to build it all. You get to create the states that you want. You get to create the transitions. And once you've done that, you get to add actions to those transitions so it does things for you that you want it to do. You create the transitions based on the names of the triggers that you wrote, expecting them to evaluate to true. So for whatever you wrote, if port traffic equals true, then fire the trigger port traffic. Once this is an alarm that has a pending transition because it's turned on, that can move us to the state busy. When I'm in the state busy, the only thing that can take me out of that state is to follow the error again through the next port traffic trigger. And that will transition me to the state of too busy. We get to add them. We add states by clicking on the blue oval in the upper left-hand corner, naming the state and selecting the severity. Clicking OK, and it adds it into this window, and then we get to move it all around and drag it around and place it where we think it looks good. We get to add transitions by hitting the first square at the top left-hand corner. And it gives us the ability to choose from state to state on a specific trigger name. Use the trigger names you generate. You will find that in the list are all the trigger names that are available to the system. Remember, NerveCenter keeps a list of these trigger names so it can watch when there's some of them pending. You don't want to use somebody else's because you don't know what they defined to make their trigger true. In our situations, we're going to want to make our own conditions, evaluate the true, and then give it our own trigger name. And when you're all done, be sure to save. And I'll give you a little hint. You can never save too many times. There will be situations where you will hit save and you'll go to do something and what you saved is not available to you in the database. And it's because of something like you've opened a transition, you did a fire trigger with a delay, you said save, it saved it, and you think that because the window closed for the fire trigger action that it's written to the database. It's only written to the cache. It needs to be saved down here in the lower left-hand corner of the basic alarm design before it gets written to the database and made available for you to see or for everybody else to see. So save, save, and save again when you're doing your work. Well, how would I delete a state? If I didn't want the state that I've got there, how would I delete a state? Or how would I delete a transition? Well, that's what the next two icons at the top left are for. Delete the state, delete the transition. Click on it with your mouse, it'll highlight, the borders will turn black, darker. Go up to the transition delete or the state delete and click it and it's gone. And start over again. So you can add or delete here. When you want an action, double-click on the transition box. The transition box holds the name of the trigger that caused the transition. It will open its own window, and you can add the actions that you want to that transition. You can send a beep to the console. You can send a page. You can execute a command line command. Whatever. They're all there. Log to a file, send it to a database. All of it's there. You'll say OK, and then save. It doesn't save to the database until you save on this screen. When you're on a Unix system or Linux, you end up having a section. If you look at /opt/osinc/database, you will find that this is where the NerveCenter database files reside. The NerveCenter file, nervecenter.ncdb, is the flat file for NerveCenter database. That's what the NCDB stands for. And your node file is right there below it, nervecenter.node. It too is a flat file. We can take a look at NER nervecenter.node, and we can see the format of the nervecenter.node file. It starts off with begin node, name, whether it's off, on, its property groups, blah, blah, its address, and then end node. And then a next line is a begin node. So every node has all of this format in it. And there will be this type of stanza for every node in your node list. That's where it gets put. The database, it's a flat file. It's right there, nervecenter.ncdb. I can actually read it. It starts off with the groups, the property groups that are in NerveCenter. It moves on after all of the property groups to the Perl subroutines. Notice there is a Perl subroutine in this one. Begin Perl sub, the name, and then the context, notes, and other such things. There's also a rule. The rule is the action router rule. That is in here also, the begin rule. There is a list of the severities. Remember I showed you, we talked a little bit about the severities, the colors. It tells you here the severity, the name, the group. It even gives you the color that gets painted on the map and the level, etc. It's all in the database. Then there's your masks. If you write trap masks, they are here. Let's take a quick look and see where the first mask is. My trap catcher. That's the one I just wrote with you guys, right? It's right here. My trap begin mask, my trap catcher. It's turned on. It's a simple trigger. The trigger name is my all traps. It's looking for generic of -1 and a specific of -1, which means all. Its version is a 1. It's enterprise. It's using shared curl, and that's the end of writing the trap mask. So your trap masks are here. All of the other masks. Look at this mask for writing for collecting events from the collector. It goes on for quite a bit. Other masks. Your polls are written here. You can see your polls. There's a poll on this machine called gathered data, and it uses a base object of IF entry. Its property group is hubomatic. You think it's for the class? And the poll condition is written to say if IF entry dot the in octets is present, and the out octets are present, and the interface type is present, and the description is present, then fire a trigger called gathered data. That's a data logger. It just goes out and grabs the data and logs it. Other polls, etc. I highly recommend that you do not go in here and mess around too much with the NerveCenter database. You can make changes that will mess up all kinds of things on you. But that's where it's located, in the default installation directory under /opt/osinc/db for database. One of the important things about learning how to write a trap mask is that an inform from NerveCenter is in the form of a trap. A trap with 17 very specific var binds sent with it. And the only difference between it and a trap is that it is done via TCP and not UDP, where it is a guaranteed delivery mechanism versus the unguaranteed UDP protocol. It's going to retry it until it successfully gets an acknowledgement that it sent the trap was received. So that's the only difference between an inform and a trap, is NerveCenter sends its informs, which is a trap, in a guaranteed mechanism. So you'll write a trap mask that will catch, guess what, 136.141.78 because it's NerveCenter. And then you'll have a specific number in it because you'll assign a specific number to it. And then you'll be able to interrogate all 17 var binds and see the information that gets sent over in an inform. Two more concepts or pieces of the NerveCenter toolkit that are of very great importance to us. The alarm scope and the property groups. Let's say that these are probably two of the most important things you're going to deal with after you've put everything together. You're going to focus on these two pieces and make sure that the scope of what you're doing is correct and that the property groups are aligned so that everything works as you expect. Inside of NerveCenter, the concept of scope is important in that, do you care about the entire network, a node, an interface, or specific information under that interface? To think about this, maybe it's easier to look at it and think about having a couple of automobiles in our garage. Car 1 is a Aston Martin, and car 2 is a Ferrari. Let's say we're a car rental company and we rent expensive automobiles. When something happens to a car in their inventory, they need to know about it. so that they can have it fixed, so that they know that they don't have it available for renting, etc. So what if NerveCenter could poll for these specific pieces? Things like the make, the model, the tire entry, meaning the brand, the size, the pressure, whether it's flat or not. And while it's there, could it look at your brake entry and decide whether your brand or the wear is down or if there's a failure on it? Very possible. These things could translate to a network type of device. Here's what happens. The girl in the front office, the only thing she knows is there's 2 automobiles on the company list that she can rent, an Aston Martin and a Ferrari. So for her, her scope is the node scope. Which one of these 2 is available? At the upper level is the enterprise scope. Is the company able to open because everything's there or something is there? So at the enterprise level, enterprise scope, the company looks at everything. It gets the first piece of information that's necessary, and that comes from the entire company-wide situation. As I said, the girl in the front office who looks at the node scope only needs to know whether she can rent the Aston Martin or the Ferrari. For some reason, let's say that the Aston Martin has a tire that's flat. It's tire 1. She doesn't care about that. She just cares that the Aston Martin is out of service. But the mechanic in the garage is going to get the notification on the sub-object scope level that the Aston Martin has tire entry, tire 1, flat. He's going to be able to go in and look at the information below that and decide the type of tire, the pressure it's supposed to be, and where he can order one, etc., and get that car back into service. So the mechanic is focused on the sub-object scope. The guy in the parts department is looking at the instance scope. While I'm there looking at the tire, how are the brakes in that location? Are they okay? Should I have them fixed? Should I order them too? Now the mechanic may be interested in the instance scope himself, but more likely he's interested in the sub-object scope. But the guy in the parts department is definitely interested in, if I got to order a tire, what else do I need to order for this machine, for this car? So that's how it breaks down. 4 levels of scope: enterprise, node, sub-object, and instance. Enterprise. Did I get a link down from something on my network? Don't care which device. Did the something give me a link down? Node scope. Did I get a link down from a specific node? Which node was it? Sub-object scope. Did I get a link down on a specific interface? A dot something, a dot 1, a dot 3, a dot 200. Did I get a sub-object link down telling me, while I'm there at that dot 1 or dot 3 or dot 200, is there other information I can use associated with this sub-object, this instance of that sub-object that I need to know about? And that becomes the instance scope. I want to be able to detect high traffic on any interface. Well, that would be sub-object scope. What if I want to detect several conditions on any interface? That would be instance scope. What if I want to monitor each node on which a particular condition occurs? You're talking about node scope. And the last is, I want to be able to be notified the very first time that high traffic occurs anywhere in my network, on any interface. That's enterprise-wide. That's an enterprise scope. Most of the time, you will use node scope, sub-object scope. Some of the time, you will use instance scoping. And very, very infrequently will you use enterprise scoping. But it's still available to you. So when you build your model, your alarm definition, and you give it the name, right beside it is a property group, which we will touch on next, And beside that is a scope. You need to decide what scope the model that you are building for the behavioral that you want to create needs to be set at. You will need to change that or make it set it to what you wish. So now when we build a alarm definition, we've got to give it a name, and we've got to check the scope. What's the scope that we want it to run at? The alarm instance scope monitors all the nodes managed by the entire NerveCenter server. An alarm instance with node scope monitors a single node. A sub-object scope alarm monitors a sub-component of a node, usually an interface. And then an instance scope lets you monitor different base objects within the same alarm instance for that sub-object. When we have a model, an alarm definition that is set to node scope, and a trigger happens, we get an instance in memory that is tracked by the name of the node and nothing else. If I have that same alarm definition created and I have it set at sub-object scope and something happens to fire my trigger, we get an instance in the alarm summary in memory, not only tracked by the name of the node, but by the sub-object number. Node Cindy, sub-object IF entry.6. So it's tracked in two ways that it becomes associated. And that is how we can look at it and see that it is a sub-object, because it has a dot number. Property groups are containers. They contain properties. The properties are either MIB base objects, such as you see here, AT entry, IF entry, interface, could be system, could be an ATM value, ATM base object, a bunch of them. Or a user-defined string, something like router, switch, brub, Cisco devices, building 6, things that you want to be able to isolate and contain against the set of nodes that point to that property group. A node must have a property group, one and only one. One node, one property group, many, many possible properties. So it's a one node to one group to many properties relationship. We define these property groups when we set up our NerveCenter servers. The first thing that we need to do is account for the base objects that are going to be polled against those nodes. Any base object that you need to poll for that node must be in the property group list. If I'm going to poll node Cindy for system description, then the base object system needs to be in there. If I'm going to poll node Cindy for IF errors, then the IF entry base object must be in there. Any base object that I need to poll must be in the properties list. We'll see there are other rules that make this pretty well pronounced and see why it happens. How do I go about making these property groups? How do I see them? I connect with my client and I click on the property group icon at the top, or I pull down the admin and I click on property groups. And in the left-hand side of my display lists the property group by name. In the right-hand side are the properties that are in that group. And down at the bottom I have the abilities to add new groups, merge groups, add new properties, convert, do MIB to groups, all of which we will talk about here in just a few minutes. So I can highlight any of these property groups in the left-hand side and see what the list of base objects are. Now let's say I'm going to be dealing with a brand new device, one that I've never had before. The first thing I should do is I should get that MIB from the vendor. I should read through that MIB and understand what the capabilities are for that device. Then I should compile that MIB into NerveCenter, into the NerveCenter.mib file that is provided with the server. Add to it, build it, so that when NerveCenter needs to poll the base objects for that new device, they are in the NerveCenter MIB file. Great. I found the device, I got the MIB, I read through it, I compiled it. Now what do? The first thing I should do is I should do a MIB to group. Come to this page, to this window. Open the property groups, click on MIB to group. It will pop open a new window and it will show me the names of the MIBs that I have compiled inside of the NerveCenter MIB. Scan down the list and find the name of the MIB for that brand new device we just added. Click on it and complete the MIB to group. That will create a property group by the name of the MIB, and it will contain all of the base objects for that MIB. Once you've done that and you have saved it, you can then go build polls by hitting Admin, Polling List, New, start defining your poll, and one of the first things you have to do is choose the base object. You can choose the base object from that new MIB that we've just compiled and inserted as a MIB to group. If you don't do a MIB to group, you don't have the ability to build polls based on those new MIB attributes, those new MIB base objects. So remember, if you're doing something new, if you add a new MIB, don't forget to do the MIB to group. Create a property group that has the entire set of base objects in it. If it's too much, great. We'll show you how to pare it down to what you want. Or create a new group with some of the base objects from that big group that you want to have in it. No big deal. We can pare it down. We can build it up. We can give it a new property group name. We can call it by the device, the new type of device, and call it group. As you notice over here, we've got the Chipcom MIB, the Cisco Router 10 MIB, the Compact MIB. These were done with MIB to groups. HPUX MIB, those are all the base objects. This 3COM ECS switch, these are the types of things that are the possibilities for base objects that are in it. It's all done from the client, and it's all done in the property group list. According to this exercise, it believes that we know what we're doing. And it says that we have configured a poll. The poll is named My Poll. And it's written so that it will test for the following condition. And the following condition is if system.sysDescription is present. If that returns true, it's going to fire a trigger that we've defined. So the condition is if system.sysDescription is present. Doesn't care what it is. It just wants to know that the value is returned. We assigned that poll the property called MyRouter. You can assign properties to alarms and to polls. Now the property MyRouter is what? It's not a base object, is it? It's a user-defined property. We created a property group from scratch, and we named that group My Group, and we assigned the MyRouter property to the group. You then configured a node. The node's called MyCisco. It's named MyCisco, so that it's a member of the My Group. For the purpose of this exercise, we can assume that there is a no prop, meaning no property necessary, on the alarm. There's a no property alarm definition set up and ready to go, and there is a pending transition which matches the trigger's name. We don't care what it is, but it's a pending transition and it matches the name. We've got a property group called my group. It's got a property called my router. We got a node called my Cisco, and it's been assigned to the property group my group. We've got an alarm that's been written with no property as its property requirements, and it has a pending transition. So with all of that stuff in place, let's answer these questions. Assuming that my Cisco has the SNMP agent available, it's properly installed and properly configured, my pole will query my Cisco and the condition will be true. Is that true or false? Now the condition we're looking for is system.sysDescription. The base object of that condition is system. So, will number one be true? Will my poll the Cisco, my Cisco, based on the contents of my group? It will not poll. Can you give me the reason why it won't poll? The alarm definition has no property, but the poll has a base object of what? System, because the condition we're polling for is if system.sysDescription is present. So the poll has a base object of system. Properties within the property group have to be the base object that you want to poll, right? So the property group, my group, doesn't have a base object in it called system, so therefore the poll will not run and it will not poll the device, my Cisco. I can fix it by going back and adding the property system, which is a base object, to the property group, my group. And then the poll will work. So there's a little bit of a rule in there. The rule for this is that the base object of the poll must be in the property group for the poll to run. It doesn't work, and it doesn't work because of the rule for base objects. Let's take a look at number 2. My poll, which we consider to be if system.sysDescription is present, will poll my Cisco if the device's property group, my group, had been created by copying the MIB2 MIB or created based on the RFC 1213 MIB instead of being built from scratch. Now, is that true or false? You guys are clicking around, I hope, at property groups, and you're looking at the MIB2 group down there, and you're saying, if I had copied it, does it contain system? It does. So that would have been yes if it had been done from the MIB2 group. It would work because system, the base object, is in the property group list. See how that worked? It would also be true for RFC 1213 because the RFC contains system in it. I don't see it. MIB2 group. Let's see if we can find the RFC over here. RFC 1213. It's right there. Does it contain system? It sure does. See it? Right there. So if I had used RFC 1213.mib, it would also be true for that one. Again, the base object that we are polling for must be in the list of properties for the poll to run against the node that it's pointing at. Let's look at number 3. If an alarm can be instantiated only by a trigger from my poll, then that alarm must also have the property of my router. How about it's false? The alarm, in this particular case, has no property associated to it, and it works as long as the base object is in the property list, in lists of properties in the property group. So it does not have to have a property of my router assigned to the alarm. The alarm can have no prop, or it can have any other property that is in the My Router group or the property group. It could have a system property assigned to it, and that would work because system is assigned to the alarm as its property, and system would have been in the property groups list if we had copied from MIB2 or 1213 RFC. So we now hit another rule, and the rule that we're hitting here says if the alarm has a property assigned, the property that it is assigned must be in the property group. The interesting thing here is it does not have to be a base object. It's most likely, and in many cases, the user-defined property. And this is where you would use user-defined properties to your advantage. I build a model. I create property groups. In that property group, I call this Router Group A. I put in a property called Router Group A. I build an alarm. I assign the property to the alarm Router Group A, and I put a bunch of nodes into that property group, and it will run that alarm against the nodes as long as they're in that property group and the Router Group A property is there. I get too many of these routers, and I want to break this group up and make it a little easier to manage. I go in and I create a copy of the property group that has everything in it, including Router Group A. I delete Router Group A and I change it to Router Group B, and I save it, and I now have a second unique property group with Router Group B. I copy my alarm, completely copy it, and before I save it, I change its property to Router Group B. I turn it on. I change my nodes. I put some of them in Router Group A and Router Group B. I now have divided my workload from 500 nodes polling in this particular situation. I cut it in half because I put half of them in Router Group B and the other half in Router Group A. The property Router Group A is assigned to one alarm. The property Router Group B is assigned to an exact copy of it, but it's in the other side, and that way I split the workload. See how that happens? By using a user-defined property, I can split the workloads. I can shift things around. Why would I want to do that? Well, maybe at some point in time I've got 500 nodes, and this particular poll goes out and it polls for so much stuff that it puts a big workload on the system for several minutes. And it slows my NerveCenter server down because I just went out and polled for a whole bunch of tables on 500 servers, on 500 nodes or 500 routers. If I want to stagger that in the polling cycle, I split the property groups, I split the nodes up, I create two separate groups with 250 in each, and I do this little trick with the property groups and the property names. I now don't get that big drag on the system because I've only do 250 on this cycle, and a cycle or two later I do the other 250. They still get polled, they just don't get polled all at the same time, and I don't overload the system. I can even my polling out. I can smooth out the way NerveCenter is running. And this can be seen in servers that are running by tracing the counters and tracing the queues. So that's the other rule. So we've hit two rules about property groups and polling. If we're going to poll, the base object of the poll has to be in the property group. And if the alarm has a property assigned, then the alarm's property must be in the property group for it to work. If I've got a poll, and the poll can have a property and a base object, then wouldn't there make sense that there is a rule for the poll, if it has a property assigned, that that property must be in the property group? Well, there is. So that's the third rule we've just hit. And the fourth rule, there must be a pending transition. So from this exercise, we can determine that there are 4 specific rules for polling. They're known as the golden rules for polling. The first rule and the simplest rule, there must be a pending transition. That transition has to have the same name of the trigger that's going to fire it. The second rule is the alarm rule. If the alarm has a property assigned, that property must be in the property group. The third rule, the pole rule. If the pole has a property assigned, that property must be in the property group. And the fourth and final rule, and the one that catches a lot of people, is what we call the base object rule. The base object of the pole must be in the property group. The golden rules for polling. Polling definition basics. If any of you are familiar with some of the other platforms out there, uses thresholds to send us information, to send information up. A threshold that says, I've hit so many thousand, or I've hit so many errors, or I've done something. It's not really a decision, is it? It's just a flag. So it's just a threshold. It's a notification that we've passed a limit. NerveCenter can use those, but more importantly, NerveCenter can actually go out and get additional information and make a decision as to whether the threshold is valid, consistent, permanent, or whatever. Now, here what we see here on this slide is that a platform threshold might tell us that we've got interface inbound traffic at greater than 20,000. 20,000 what? It's just greater than 20,000. But on the other side, NerveCenter would be able to say that the interface inbound traffic and the outbound traffic is greater than 80% of the capacity, and the error rate is greater than 20% of the total traffic, then that constitutes a real situation. A lot different, isn't it, than just saying, oh, I got inbound traffic at over 20,000. How do we do it? We do it by the way we write NerveCenter polls. This is an example of a NerveCenter poll condition. This is a delta. The delta is the difference between two consecutive polls. The delta, the time difference, is based on the interval time that we assign to the poll. So if I were to have assigned a 1-minute polling interval, then this delta would be in a 1-minute snapshot. It would take the values the first time, wait 1 minute, take the values the second time, then calculate the delta and evaluate the condition. And that statement on this page, if inbound and outbound traffic is greater than 80% of the capacity and the error rate is greater than 20% of total traffic, this is that same expression written in a NerveCenter poll. If the delta of interface in octets and the delta of interface out octets times 8 divided by the elapsed time times the interface speed is greater than or equal to 0.8, 80%, and the delta of interface in errors and the delta of interface out errors divided by the in octets, the delta of in octets and the delta of out octets is greater than 0.2 or 20%, then fire a trigger, error traffic. The power of the NerveCenter poll is making a scientific equation, an evaluation for us, determining the outcome to be true and firing a trigger. It's actually calculating a scientific formula here. Now, I know this looks daunting, being some of the first days you see NerveCenter, and not all of your polls will be this complicated. But this gives us an example of how NerveCenter can take something as simple as a threshold and actually determine if it's a real error traffic, high traffic situation. It takes no longer to get this than it does to sit there and get 2 of those thresholds at a minute apart. So, an example of the poll. How do we write pole definitions? We go to our client. We open up the admin. We go to the pole definition list. We click on it and we open a pole definition and we click on New. It is normally filled. It's empty. There's nothing to it. It would actually be on the pole tab and not the pole condition tab. You're on the pole tab now. You would fill in the name of your pole. You would select a property. What about the property? It would need to be in the property group for the node that we want this pole to work on, wouldn't it? We're going to leave the port field empty for now. We'll talk about ports later. If we want help, we can click on the help button and it will explain to us the options for the port field. We fill in the polling rate. How frequently do we want this pole to run? In this case, it's 30. And we click on seconds. And then the pole condition down on the bottom is actually filled in by going to the pole condition tab, selecting a base object, and then selecting the attribute and writing our statement in the pole condition down below. And what's really interesting here is in this pole condition box down below, you can use a right-click mouse function to help you build your poles. We'll see how that's done here in just a couple of minutes. When we're all done, we try to save it. If the Perl that we have written is sound and can be parsed, it will save. If it can't be parsed, it will typically tell us that there is an error at some line number. You'll have to scan through and figure out what your error is. Could be syntaxed, whatever, too many spaces, not enough parentheses. Back in this, you notice the brackets after the if statement. There's like 3 of them. We have to have the complementing number of brackets all the way through this thing. So that has to be accounted for, and that's part of Perl. If the delta in octets is greater than 5, fire the trigger port traffic. In this particular slide, we're simply selecting IF entry as the base object. Once you select a base object, all of its possible attributes under that base object are available. Of note here, you can only select one base object per pole. You cannot do an IF entry, IF description, and then follow it with is system dot something there. Because you're changing the base object, it does not work. One base object per pole. The golden rules of polling that I mentioned. I have my client in front of me. Admin, poll list, new. It comes up and tells me the property is no prop. That's the default, and that's a good idea. Leaving it at a default. I give it my name. Test poll. I want it to be every 30 seconds. And then I go to the poll condition list. Now, what am I going to poll for? I'm going to poll for a set of attributes based off of a base object. So the first thing I need to do is decide what my base object is. How about we look at system? We'll select the base object system. Notice now over here on the right-hand side are all the possible attributes for the base object system. Here's what I mean when I said you can right-click in this space down here and build. I'm going to write my poll expression that says if, bracket, the system description. And did you see that? I just double-clicked on system description and it filled it in for me. If the system description, right-click. I can do arithmetic, logical operations, relational operations, Boolean expressions, other functions about assigning property groups, doing deltas, looking for elapsed fire triggers. I have node name variables and poll key host name. If it's grayed out, it's not available at this time to you. So, if I'm going to do relational, did you guys see present here? Right there. If the system description is present, that's all I care about. I don't care what it is as long as there is a value returned to me. If system.sysDescription is present, bracket, enter, squiggle, enter, right-click, other functions, fire trigger. The name of the trigger will be, quote, got underscore system, quote, bracket, semicolon, enter, and then you need to end your Perl expression with the other squiggle. That is a poll expression. If the system description is present, fire the trigger, we got system. If I click on save, it saved for me because I completed the Perl correctly. I now have a poll written that goes out and checks for system description. I might want to come back here and say, and system name present. Save that. I'm checking two variables. If the system description is present and the system name is present, fire the trigger. Let's go back and modify it even further. And if system location space present, let's save that. I can add to it as I go along. The thing here is that I am creating an if condition. If condition returns true, fire trigger, trigger name. Use the right-click button to build this. So if the system description is present, and the system name is present, and the system location is present, fire trigger got system. Well, what can else I do? Else, I can give it an else and say, look, if those are present, do this, else do that. I can choose and give it two triggers to fire. It can only fire one. So if it reads down through that first if statement and that evaluates to false, then it will take the else condition and it will fire the other trigger, no system. I can save all of this, go back and close it, turn it on, and then I can go build an alarm definition and use the two possible triggers that I've named here to do things for me. That's a good one, so we'll save it and we'll close it. You're going to build something, you're going to turn it on, you're going to say it's not working. I'm going to say, did you go through the rules of polling? And you're going to have to go back and step through these one at a time and verify. Is there a pending transition? What does that mean? Do I have a trigger in this alarm that is named after a trigger that can be fired in either a poll or a mask or a subroutine? And is it all turned on? If it is, then I have a pending transition. Does the alarm have a property assigned? If it does, then I have to have that property in the property group. But if it's no prop, then move on to the next rule. Does the poll have a property assigned? If it's no prop, move on. But if it has a property, then you must check to see that that property is in the list of properties for the property group the node is assigned to. And the final one is a must. The base object must be in the property group. The base object of the poll must be in the property group of the node that you're looking at. Let's take a look at this polling list that I have here. There seems to be some interesting polls here. What's the authentication failure poll say? It's a delta poll. So if the delta of SNMP in bad community names is equal to a 1, or the delta in bad community uses is equal to a 1, greater than or equal to a 1, fire the trigger, auth fail. Let's take a look at a couple of the other ones. How about gathered data? If I look at the poll condition, it's pretty straightforward, isn't it? If the in octets is present, and the on octets is present, and the type is present, and the description is present, fire a trigger called gathered data. This is a data logger. Your management team says to you, I need to know so many times a week how much there is a load on the network. You can write a gathering data poll that goes out and queries certain devices for their load statistics. And you can use the fire trigger, gathered data, to log it to a file. And when you're done at the end of the week and your management wants a report, you send them you do a Perl script that you write that scrapes the log file and puts it all into a CSV format. And there he has this neat little spreadsheet in front of him weekly that says, here's the data I gathered, and at these peak times during the week, this is the amount of traffic on my network. Again, a data gatherer. ICMP echo. A little bit complicated, because it makes calls to Perl modules held inside of NerveCenter. Use config and use switch. Those are Perl modules inside of NerveCenter that it makes calls to. Here's a whole series of comments explaining what this thing is meant to do. It's practically a book before it actually does something. If you're going to write something this complicated, you need to put comments in it so whoever follows you can come back and take a look at it. Put a pound sign in front of it. It's commented out. It doesn't get operated on. To notice down here at the bottom this little thing called notes. You can add notes to your polls, to your alarms, and give them tips and information. Record a trace of ping responses to a comma-separated value log file. Fire ping to response when NL ping response is value, meaning an ICMP echo was returned. Otherwise, fire ping to no response, meaning an ICMP error packet was returned. Usually a destination unreachable event was put in there by the engineer who wrote this one. This is a diagram, an alarm diagram. And it's been simplified, as I said, to show us not just the name of the trigger, but what causes the trigger to transition. In the case of going from ground to state 1, there is a trap indicating that we have high line card activity. It's what it's telling me fires the trigger. Once I'm in state 1, we know all about traps. That's not a difficult part here. But what becomes difficult is once we reach state 1, there are multiple ways to come out of this state. Notice there are 2 arrows that leave, multiple ways to leave the state. If I take the transition from state 1 to state 2, it tells me that that transition comes from a trap indicating high line card activity. Well, that's the exact same trap that got me here from ground. So I'm aware of what that trap is doing. Okay, that's one of the possibilities. The second possibility comes from state 1 and goes back to ground. And the action that's causing its trigger to fire is no traps for 60 seconds. In other words, after a 60-second timer, if I haven't received any more traps to take me out of state 1, this trigger will fire and it will take me back to ground, removing the alarm from memory. This allows me to set up a series of states and checks and timers that says, I got a trap high line card. I'll sit in this state for 60 seconds. If nothing happens, I go back to ground. But if I get a second trap quickly, before 60 seconds, I will fire the transition, the trigger that takes me from state 1 to state 2, based on that trap indicating high line card activity. And if you notice, I have a 2 ways out of state 2. One of them goes to state 3, which is the third one, the third trap. Or I have a transition that takes me back to state 1 saying I didn't get a trap for 60 seconds. In essence, this alarm diagram, this behavioral model is catching traps, waiting for 60 seconds to see if it gets another one. If it doesn't, it goes back to the previous state. Could be ground, could be state 1. But if it catches the first, the second, and the third, notice that there is no way out of the third state. And that says we have a serious issue. In other words, we caught more traps saying high line card activity than were allowed for in a possible 2-minute period here. Possible 2 minutes because of the first 60-second timer, and possible because of the second 60-second timer being added together. So I'm waiting, in essence, for 3 traps to happen inside of a quick 2 minutes here. And I'm also tracing myself to way back. Well, how do I set this up? How do I make this work? I'm familiar with writing a trap mask, and that trap mask can sit there and say, I'm waiting for high line card activity. But how do I fire a trigger with a 60-second delay to take me back to ground? I do that in the transition going into state 1 from ground. I double-click on the transition. I add an action. The action that I'm going to add is a fire trigger. I select the fire trigger action. A pop-up comes up. I give it the name of the new trigger, the name I want it to use when the timer expires. And I can set the timer value right there in that same pop-up. In this case, I'm going to call my new trigger No Traps. I'm going to give it a 60-second timer, and I'm going to save it, and I'm going to save it again so that it's written to the database, and then I'm going to come back to my alarm definition that I'm writing, and I'm now going to create a transition from state 1 back to ground based on the name of that new trigger, No Traps, that I just created with a timer on it. And that's how I create timers. On the transition into a state, I add a fire trigger with a new trigger name, with a delay, the time that I wish. I save it. I come back and I use the new trigger's name to take me out of that state that I just set it going into when the timer expires. It doesn't have to take me back to ground. It can take me to other places. But the whole purpose and the whole principle here is you build and set the timer going into the state, and you use the result of that timer, the new trigger name, to take you out of that state. Make sense? So in the case of this diagram, how many times would I have to build timers? I'd want to build 2 timers. 1, 2, actually 3. The first timer I would build on the transition from ground to state 1. The result of that timer would take me back to ground with no traps. The second timer would be on the transition from state 1 into state 2, telling it to take me back to state 1, and I would cause the transition to go back to state 1 when the 60 seconds times out. On that input that I just described, that no traps back to state 1, I would also want to set a 60-second timer there to take me back to ground if nothing happens in that state for 60 seconds. So I would have to create 3 separate timers here. By creating the first one and making it 60 seconds and using that 60 seconds no traps all around, I can reuse it after I create it the first time. because it's doing the same thing. So in this way, I can induce the concept of time. I'm going to wait here for 60 seconds. If it doesn't take me out, then I will fire a trigger that takes me someplace else. And I can do either nothing, or I can take another action. I can go back to ground. I can do several things. And that's how we do it, by using the transition and the actions that we can add to the transition. This particular action is a fire trigger, and a fire trigger with a delay. It creates a timer for us. Real quick, let's go see if I can show you a little bit of that here. Let me take the original all traps, and I'll move this. Notice the only thing in this transition is a log to file. But let's say I want to go back to ground if I don't receive another trap in the all traps loop up at the top here, this loop, in 60 seconds. I would do it this way. New action, fire trigger, the trigger definition window opens. I give it the new name, back to ground, and I set it for 60 seconds. And I say, okay, okay. Now my new trigger name was back to ground, right? So if I go up here and I add a transition that goes from logging back to ground, on back to ground. Oh, it's not there in the list, is it? Do you want to know why? Because I didn't save here. Now that it's saved, this will be available. So let's go try that again. I want to go from logging back to ground on the signal called back to ground. It's now in the list. That's why it's save, save, save. And now I have created a timer for the logging state that says if I get here, I'm going to start waiting 60 seconds. And if nothing happens, I will fire this trigger called back to ground, and it will take me back to ground. Now, remember earlier, if I right-click on this, it tells me it comes from a mask, and the mask is called all traps. What happens when I right-click on this transition that I made? It tells me that this trigger comes from an alarm. I can look at the alarm, and it tells me it comes from the alarm that I am on. And if I click on that, it's just going to stay right here. So I know that this trigger was fired in this alarm someplace, and I can simply double-click and say, there it is. It's the fire trigger there. Is it over here? Nope, I don't have to worry about it. But in this particular case, because we're looping, we probably would want to add the timer to this looping state, just like we did to this transition state from ground to logging. So let's do that. We'll double-click. We'll take a new action called fire trigger. Now, because we've already set up a name called back to ground, we can use it. Back to ground for 60 seconds, and I can say okay, okay, and save. Now, the interesting thing is I don't have to add the transition. The transition back to ground is already there. I'm just reinitializing the waiting. Every time I get one through that loop, I'm going to wait again. I'm going to wait again. I'm going to wait another 60 seconds. I've changed my basic all traps model to have a timer that will take me back to ground if I don't receive a trap in 60 seconds. And you saw how I added it. Can you see the usage of timers now to NerveCenter? I got a trap. I'm waiting here. I'm waiting here. NerveCenter goes out and it's polling and nothing's coming back and it's getting timeouts and stuff and it's not happening. And how long am I going to wait here? A day, 2 days, forever? Is it just going to hang there? I can build a timer that says, hey, if the poll doesn't run inside of 2 minutes, it's probably tried itself out and it can't connect. Let me fire a trigger and go to another state. And on that transition to the new state, I can put a serious or pretty high severity inform over to the knock and says, I've tried to reconnect It's failing. Send somebody down there to fix this. So you can see the use of a timer there. How about in the case of login failures? 3 login failures inside of 2 minutes is a perfect example of using not only the timer, but a counter. And the counter is going to sit there and say, if I count before this thing hits 3 minutes, I'm going to take off and say I've got a problem. I'll fire a trigger and I'll go do something special. This diagram shows us that we are watching for high line card to happen, and if we get more of them, we get at least 3 of them in 2 minutes, and it's 60 seconds because it could actually wait 59 seconds before it gets the second trap, and 59, so it's literally 2 seconds less than 2 minutes is what this times out to be. How do we do it? We do it with, as I said, a new fire trigger action in the actions list. We give it a name, we give it the time, and we can leave the sub-object and the node and the property stuff all basic default because it will match what started the alarm. What other things can happen? Well, we can also add an action in there for clearing triggers. Why would I want to clear a trigger? Well, in the case of the diagram I just did, I would want to actually put a clear trigger on this transition here, the looping transition, because, and let's think about this, I'm in ground, I get a trap, I come to this state, I set a timer counting for 60 seconds to take me back to ground. At 30 seconds, I get a new trigger. I get a new all traps. So I loop. I come back. I'm in this state. I set that timer to 60 seconds. What happened to the timer that was there before it? The one that this guy started. It could still be residual. It usually takes the server more than a second or two to clear these things. And in the case of a looping transition, it's back there too fast. It's going to have a residual counter or timer, residual timer that's still ticking down, just probably got 15, 20 seconds left. And you're going to set a new one. So to avoid having residual timers, you make a clear trigger action by double-clicking on the transition, adding a new action, and the new action is a clear trigger action. And what's the trigger we're going to clear? We're going to clear the trigger called back to ground because that's the one we're timing, right? So we will select it from the list and we will say OK, OK, and save it. And now, if I come off of ground on an all trap and I set a timer and I get another all trap immediately, on the looping transition, I'm going to clear the residual trigger and set a new timer to 60 seconds. How do I know it's going to happen that way? If I double-click on the transition, you will see that the clear trigger comes to the top. One of the things you need to remember about NerveCenter, in the transition definition list of all these actions, the only action that takes a precedence is the clear trigger. The rest of the actions can happen in any order. But a clear trigger will always happen first if it's in the list. And if there are multiples, it will fire the multiples. Before any other action gets taken, it will clear the trigger. So it will make sure that residual is gone before it tries to set a new timer to 60 seconds. Rule of thumb, if you're writing a timer, you should clear it when you come back to that state. Do I have to clear it when I come from ground into that state? No, I've been in ground. There's nothing in memory. I shouldn't have to clear it. If you want to practice rule of thumb, sure. Let's go here and let's put a new action for the clear trigger, and we'll select the same clear trigger back to ground. We'll say OK, OK, and we'll save it. And then we've met the standard practice that if we set a timer, we clear the timer. And it'll be in the list. And it'll always be at the top. The actions below it could be in any order and will be taken in any order. But the clear trigger is at the top, and it'll always be at the top and takes precedence over any other action. Another possible action that we can do in a NerveCenter transition is an inform. An inform to either a NerveCenter platform, an OpenView platform, a NetCool platform, or something else that's prepared to talk to NerveCenter and work by accepting our traps. An inform action. In the original diagram, where would I want to inform? I would probably want to make my inform on this transition from state 2 to state 3, because that's the one where I have a problem. I know my severity level has gone from warm blue to warm yellow to red. I'm in a high-level situation, and that's probably where I would want to do my inform. Let's look at the NerveCenter model that we were just playing with. I could send an inform in this transition or in the other one. Wouldn't matter, because at this point I'm not getting to a severity state. I'm just counting these things and looking at them. And this is how I would add an inform in this transition. By double-clicking on it, new action, and I would do an inform. And the specific number of the inform would be something that you would have to figure out according to the platforms that you're working with. How do I do that? Well, let's hit the help button. Love my online help. Inform. Once NerveCenter has used its event correlation abilities to detect, it can do an inform. To add an inform to an action transition. Inform specific numbers right there. Type a number normally between the range of 100,000 and 199,999. Those are the normal ranges. Here's what specific numbers can do for you, and there's information here. The whole point is you get to choose what you put in here according to your usage, according to the number. So here's where you put the inform in. 100,000, 199. And you say okay, and you say okay, and you save it, and it's ready to do an inform. While I'm talking about informs, we should make sure the server is set up to do informs. Where do we make that? We make that determination from the admin. Log into the administrator. You might want to size it so that you can see it. We have a tab. Inform configuration tab. We click on that tab. I have nothing here in the list, so there are no inform recipients ready to go for me. I'm going to send informs to myself at this moment. So I will put in the number 58.132. That's the machine number of my machine. What type of informs am I going to be doing? Am I going to be doing NetCool informs or NerveCenter, Command Center, OpenView informs? I have to select those. Depending upon which one you select, there is a set of ports numbers that need to match here. 6024 is for OpenView. You need to read the help again, and we will take a look at Inform Configuration tab field variables, the port numbers, and to the port number that your NerveCenter server will use to send the informs to the recipient host. 32505 to send informs to another NerveCenter server. 6024 to go to OpenView's platform adapter. 32509 to send them to a Tivoli NetCool. So I want 32505 in my case. So I'm going to change this to 32505 because I'm going to send it back to a NerveCenter. Now the next thing you need to check is the event notify on. Event only, symbol only. Here's what happens. When NerveCenter sends an inform to NetCool or to NerveCenter, it is an event only inform because we don't change symbol colors. However, if I were going to a OpenView platform for HP, I have the choice to do either or both. An Inform to OpenView can do both event and symbol changes. In other words, the event gets sent to the event logger, and the symbol will change the color of the symbol in the OpenView presentation. So when you do your integration and you're with OpenView, read the integration information, because there are a couple of steps you need to take on the OpenView side to make this Inform with symbol color change work on that side. In our case, we're going to be doing an event only. The next field is minimum severity. I leave this at 0 because I want even the smallest level of information to be accounted for. I could change this up to a 6 or a 7, and then only events that have a severity of 6, 7, and higher are going to be sent, and all the lower level ones aren't going to be sent. You might want to change the level that gets sent here. Properties gives me the ability to choose a specific set of properties that must be accounted for in the alarm before this Inform gets sent. And I can build that property list by looking at the help and typing in the $ properties and stuff that I want. And then to complete this, I do an add. It adds this information to the recipient list so that the server, the NerveCenter server, will now have an IP address. It's going to know whether it's doing event and symbol only, and whether it's a NetCool or a NerveCenter OpenView. And I'm going to add that. And the data was saved successfully. And now my NerveCenter server is going to be capable of sending Informs to itself. If I wanted to send it to somebody else's, I could go up here, put in a different machine. So 50.16.81, and I'm going to make him an IBM. And notice when I did that, it changed it all on me. It put the port at 32.509. I got to do this over. 50.16.81. Notice it filled in all of the other fields appropriately also when I did a NetCool. All I had to do when I changed it, it went to event only symbol level, and now I can do an add, and it will try to send Informs to your machine as if it were a NetCool machine. So now back here on this diagram, if I wanted to do an Inform to platform, this is the way you choose the numbers that go over to NetCool. Instead of just an Inform, you do an Inform to platform, and you put your numbers in here. And you say, okay, save, and lo and behold, I'm doing an Inform, and notice it says it's a NetCool Inform, doesn't it? Okay, so that's where you set it all up, and that's how we set it up. So if there's any questions about setting up an Inform or where or when, back to the presentation. So we're doing an Inform action. There's one of the other possibilities that we can do here. Now we've just seen how to set it up in the administrator and how to set up one or two of the two possible types of Informs. OpenView needs to have a OpenView platform adapter or an OVPA module running on it so that NerveCenter can send to it. NetCool must have a NetCool probe and the NerveCenter PA server application running on it. PA server, platform adapter server, that adapts to the NetCool probe software. LogMatrix is not responsible for the NetCool probe software or the probes. We only sell NerveCenter, and when you install NerveCenter, you get either the OpenView platform adapter or the PA server, depending upon your selections when you do your installation. So in some cases, if your NetCool is on its own server and NerveCenter from NerveCenter, it's a different server, you may have to go start a NerveCenter installation on the NetCool machine and add the platform adapter software there to be tied in with the probe, because it needs to reside on this machine that the NetCool is running on and where the NetCool probe is. So that's informing. Inform platform, that's the NetCool.